Right, silence now, hey. Silence. Okay, number 15. So 15 is an integral, not an antiderivative. So all you have to do is remember the fundamental theorem. Think of 1 over x squared as being f prime. Your first task, find out. Once we find f, we're just going to plug in 1 and 2. F is the antiderivative. So back to the flashcards. My first thought is, to find an antiderivative, I want to see if I can use a rule. Okay, it's 1 over x squared, not 1 over x. So the ln rule does not fit.
Can we change it to x negative?
No, keep going. Perfect.
X to the negative second.
Yeah, look, 2 points for Canyon. It's perfect. Right here. He said, the rule doesn't fit, but it's not hard to do a little algebra first, and then the rule does fit. That's what you do. So go back to here. So we say, okay, we don't do any antiderivative yet. We first just do the algebra. Question? Please, Ashley.
When you're saying it's not like antiderivative, it's an integral, is that because it has like a range? Like it has like the 2 and 1?
Mm-hmm.
Okay.
No, it's perfect. Ashley, it really is that simple. If there's no limits, the 1 and 2, then it's just an antiderivative. With limits, it's an integral, but all that's different is we find the antiderivative first and then plug in the limits.
So is that why when we, like if you do the rule, and like the integral part goes away, is that why you have to do like the line that you're talking about?
Yeah, it's right here. Ashley, you're doing perfect, really are. Look here. Equal always means these are the same, right? So this integral that we're working on, this isn't f prime. We just kind of think of it that way. Well, this integral is the same as this. So we're going to find out the antiderivative. Here it's just the rule. So I have an equal again because they are the same. So my antiderivative will be x to the negative 2 plus 1 divided by negative 2 plus 1. That's this, that's f. But because there are limits, I have to use those still. So like that. Is that really good work? Hey. Okay, look, here's why Ashley's getting a ticket. Listen.
Thank you.
No, it's well deserved. Look, okay, what she just did is what everyone has to do. Whatever it is, if it doesn't click, you can feel it. If it doesn't make sense, you just have to talk until it does. So, good work. Questions? I keep referencing Bryn and Lily's from B-Day too, so apologies I didn't mention that. But that's all we learned on the pink, really, is this right here. That's all we learned. And then we just practiced it. Questions to here? So this is what I'm thinking of as being f. So this will be x to the negative 1 divided by negative 1. Dividing by negative 1 is the same thing as multiplying by negative 1. X to the negative 1 is 1 over x. Question? Please go.
This is a small book. Why don't you have to write the plus c?
I'll show in a second. Other questions here? So the next step, Calvin will show why we don't write the plus c. So remember, the bar means it's this right here. The bar means take what we are thinking of as being f and plug into f 2 and 1 and subtract. So remember, equal means these are the same. So we started with this right there. These two are the same just by algebra. We're thinking of this as being f prime. To solve the integral, fundamental theorem says I got to find out antiderivative. So I did. Now I got to plug in 1 and 2. They don't talk while I'm talking. It messes with my concentration and yours. If there was a plus c, we'd write it like that. Then we would say subtract. Got to have a big parenthesis. Always use parentheses when plugging in values in place of variables. This would become plus. That distributes, and the c's will add to make 0. So no one expects you to write plus c if it's an integral, because they'll always add to make 0 anyway. So. Okay, anyone want to talk about that? Cool. Now we have 8 videos.